For this lesson, we need to open the sample file Bicycle Manufacturing Schedule 1 from your Sample Files folder. This lesson introduces the Solver tool. Most of the business people that take my courses have no use for Solver, but the tiny percentage that do often get wildly excited about the potential of this amazing tool. Because Solver is really an external tool that has to be installed as an add-in rather than a core part of Excel, this video doesn't explore some of the more exotic features of this remarkable tool. But there are a huge number of tutorials covering some extremely advanced uses of Solver at www.solver.com, and you'll find all you could ever want to know about Solver there. So, what exactly is Solver? Well, conceptually, Solver is similar to GoalSeek that you learned to use in the previous lesson. While GoalSeek can only change one input cell, Solver can change any number of input cells, and this makes the tool far more powerful. Let's now discuss the problem that Solver is going to solve for us, the problem that's modelled in this worksheet. This worksheet models a bicycle manufacturing company. The company manufactures 4 different types of bicycle. You can see that the mountain bike in column B requires 2 wheels, an alloy chassis, and a set of hub gears, while the street bike in column C requires 2 wheels, a steel chassis, and a set of derailleur gears. The manufacturer only has a certain number of parts available. You can see these defined in column I: 180 wheels, 40 alloy chassis, 60 steel chassis, 50 sets of hub gears, and 40 sets of derailleur gears. Now, the current manufacturing schedule suggests that we'll make 20 of each bicycle, and you can see that this will result in a total profit of $4,200. Our challenge is to maximize profit by manufacturing the optimum number of each type of bicycle. The profit is shown in cell F14, and in Solver terminology, it's referred to as the target cell. We also use some Solver terminology in cell H5, constraints. The constraints are that the parts needed to manufacture each bicycle cannot be more than the parts that are available. So in our current plan to manufacture 80 bicycles, we'll need 160 wheels, and that must be less than or equal to the 180 wheels that are available. Before we can use Solver, it needs to be installed as an add-in, unless somebody's already done that on your machine. To install Solver, I click the Office button, then Excel Options. In the left-hand bar, I click Add-ins. Then in Manage Excel Add-ins, I click the Go button, and I check the Solver Add-in checkbox. I now click OK, and if you look on the Data tab on the ribbon, at the right-hand side, a new group called Analysis has appeared, and that contains the Solver add-in. So now I'll open Solver by clicking Data tab on the ribbon, Analysis group, Solver, and Solver appears. Let's now define the problem that we want Solver to find a solution to. First of all, set target cell. Well, the target cell is that total profit figure in cell F14, so I'll click in cell F14. Next, it says what should it do with this target cell. Should it try and make it the smallest possible value, the maximum possible value, or a specific value? Well, I of course want the maximum value, so I leave that at the default, because I want to maximize profits. Now Solver wants to know which cells is it allowed to change. In other words, where are the input cells? Well, the cells that Solver can change are the number of bikes that we're going to manufacture. So that is cells B4 to E4. We've now told Solver that it must maximize profit by changing the input cells in cells B4 to E4. But I've still got to define the constraints. So I'll click the Add button to the right of the Constraints list, and this dialog allows me to define each constraint. First of all, there's a constraint that may not have occurred to you. It's obvious to us that we can't manufacture a negative number of bicycles, but it's not obvious to Solver. So the first constraint will be that the input cells B4 to E4 must be greater than or equal to 0. Now I'll add the second constraint, so I click the Add button, and now I must tell Solver that it cannot use more parts than are available. So cell references G7 to G11, the parts needed to manufacture the bikes, must be less than or equal to, which is the default, the parts available in cells I7 to I11. I now click OK, and you can see my two constraints in the constraint list. Solver now has enough information to solve the problem. So I click the Solve button, then the OK button, and you can see that Solver has increased the profit to $4,750. It's told us to manufacture 25 mountain bikes, 35 street bikes, 5 racing bikes, and 25 commuter bikes. And you can see that Solver has used all of the wheels, 180 wheels. It's used all of the steel chassis, all of the hub gears, all of the derailleur gears, and it has 10 alloy chassis left over. It's used 30 and it had 40. So that's a really good solution. All that remains now is to save your work, and I'll save it with the new name Bicycle Manufacturing Schedule 2, and as usual I'll save it to the folder above my sample files folder. I click the Save button and we're done.